Okay, so we're going to be graphing quadratic functions by factoring, implying that one of the key features that we need for graphing quadratics is the x-intercepts. And one way we can find the x-intercepts is by factoring. Okay, so hopefully number 1 looks familiar to you, but let's take a look at number 2 here. So for number 2, if we're doing it by factoring, that would imply, okay, let's make an x-factor chart. A times c goes on top, which is 8. B goes on the bottom. So two numbers multiplied to give me 8, but add to give me -6 would be -2 and -4. Okay, and I realize that A equals 1, so I can just take the shortcut right here and say x minus 2, x minus 4. All right, and if I were to set each one equal to 0, because I'm solving by factoring, because I need to find the x-intercepts, so x minus 2 equals 0, and x minus 4 equals 0. That's going to give me plus 2, x equals 2, add 4, x equals 4. So on my graph, I know my x-intercepts are at 2 and 4. All right, and that gives me part of the graph that I need. Those are two important parts. The second most important part is the axis of symmetry, which, again, symmetry means if I cut something in half, it's the same on both sides. And I want to cut this vertically in half, which, if you think about it, if those are the x-intercepts of 2 and 4, it has to be perfectly in the middle. So that would mean it would have to be at 3. But let's test our theory. So find the axis of symmetry. I'm just going to abbreviate AOS. The axis of symmetry is x equals -b over 2a. All right? And b is a middle coefficient in front of x, which is -6. So when I write this, I'm going to write x equals -6, because I have the negative with the axis of symmetry formula, including the negative that goes with the 6, over 2 times, and then a is 1. So that's going to give me -6, which is +6. 2 times 1 is 2. 6 divided by 2 is 3. So that means my axis of symmetry, this dotted line, comes down and crosses here at 3. Okay? And another key feature that the axis of symmetry tells us is that's where the vertex is going to be. The vertex, as we talked about, is either the highest or the lowest point on the graph. And it's always in the center of the graph, right? It's always going to be at the very center of the graph, just like the axis of symmetry is. So if we know x equals 3 for my axis of symmetry, then that means we know the x part of the vertex already. But how can we find the y part? Well, what we do is we plug in the 3 back into the equation for both x spots. If we plug in 3, we're going to find out what the y value is, and then we'll know what the vertex is. All right, so if x equals 3, that's going to give me 3 squared minus 6 times 3 plus 8. Okay, 3 squared is 9. -6 times 3 is -18 plus 8. 9 minus 18 is -9. -9 plus 8 equals -1. So my vertex is at 3, -1, which means it's right here. Here's 3, -1. And then all I have to do is connect the dots from here. And there's my parabola. Now notice that my parabola is a U shape, meaning it's curved. And notice how both ends are going up and out. So both ends need to face the same direction and both be going outwards as well as upwards. Okay? And another thing I'm going to have you just notice for these problems is that, look at the vertex. Is the vertex at the highest point or the lowest point of the graph? This is at the lowest point, and this is what we call, in math terms, a minimum. Okay, so I just want you to be recognizing where's the vertex. So this problem, the vertex is at the lowest point or the minimum. All right, so there's kind of a walkthrough of how to graph quadratic functions, and this is when it's in standard form. I'll show you guys another one here and go through it a little bit quicker.